Let's make finding asymptotes easy. I'm going to do one short lecture on vertical asymptotes and one on horizontal. Vertical's easier, so that's where we're going to start, and these are the examples that we're going to do. We need a little bit of terminology. I'm going to be finding asymptotes of rational functions only. A rational function is a quotient of two polynomials. It's a fraction, the numerator is a polynomial, and the denominator is a polynomial. What makes a polynomial is the exponents of the variable are positive integers. No square roots, no fractional exponents, and no negative exponents. This is a rational function in my examples. This is not because there's a square root. And this is not because there's a cube root. There's a fractional exponent. The leading coefficient is simply the coefficient of the highest degree term. So in this example, 3 is my leading coefficient in the numerator, and in the denominator, my leading coefficient is 1. In this example, my leading coefficient is -5, and downstairs, my leading coefficient is -1. There's a 1 there that you're not seeing. Okay, let's get started. We're going to find the vertical asymptotes of 9x over x plus 14. There are two steps. You fully reduce the function and then set the denominator equal to 0. This function's already fully reduced. It's factored. There's nothing more I can do. I can't cancel any like terms. So I simply take x plus 14 and I set it equal to 0. And when I do that, I get x equals -14. A vertical asymptote is a vertical line, so you need to leave your answer as the equation of a line, not simply the number 14. So the vertical asymptote, if you want to state it correctly, is x equal -14. And that is this blue dotted line right here. You can see there's a vertical asymptote at x equal -14. Here's another example. I want you to pause the video, try and factor the numerator, factor the denominator, and tell me what the vertical asymptotes are. All right, hopefully you had a chance to do that. When we factor the numerator and the denominator, we see that there is a like term. That like term we cancel out. And so r of x is equal to this function if x is not equal to 2. This function here is defined when x is 2. We're not dividing by 0. But this function up here is not defined when x is 2. So that's the difference. They're equal almost everywhere except at x equal 2. All right, so we take the denominator, 2x plus 1, and we set that equal to 0 to get our one vertical asymptote. We get x equal -1/2. Again, equation of a line. And that is the red line you see here. That's x equal -1/2. The whole is what happens when x is equal to 2. The original function was not defined when x equals 2. And when you take calculus, which I hope you do, we'll learn more about why there's a hole there and why there's not an asymptote. But for now, just stick to the simple guidelines, fully reduce, set denominator equal to 0. All right, pause the video, factor numerator and denominator, and tell me what the vertical asymptote is. Hint, there is only one. All right, again, if you don't know how to factor this, then I suggest you look up the factor formula for a cubed minus b cubed. That's a formula you should memorize. It's a factoring formula. And so the numerator factors like this, the denominator factors like this, the x minus 1's cancel. And so r of x is equal to this as long as x is not equal to 1. And then we take our new denominator and set it equal to 0 to get our vertical asymptote, x equal 3. And that is what we see right here, vertical asymptote. And I've got it graphed. It's that dotted line. This function actually also has what's called an oblique asymptote. In the next video, I'll show you how to find the oblique asymptote. And that's it.